Hello, this is our third talk about how NeoFS works. Today, we will see how objects are stored inside NeoFS. This is Alice. She wants to store a video of a hilarious cat in NeoFS. As we remember, Alice can't just upload an object, there must be a container for it first. Container has a policy which defines where and how objects inside it would be stored. There is a NeoFS network map that has information about all currently active NeoFS nodes and their attributes like country and storage device type. Applying this policy to network map, we can calculate a set of nodes that are serving the container. Now Alice calls CLI to put a video into her container. CLI connects to nearest NeoFS node and upload object there. It's a long movie, recorded in high quality, so the size of video file is quite big. In NeoFS, there is a maximal size of payload that object can have. If we try to upload a big file larger than this limit, it will be split into smaller parts of allowed size, and resulting set of objects will be linked together to let the system collect all pieces and reconstruct the original object's data later. Let's see how object enters the system and what happens next. We will look at first part of the object, the part with object ID 1. However, everything will be the same for all objects. To calculate where to put an object, we use placement function. Knowing about object, container, and a current network map, it will calculate where this object should be. Placement function returns a list of nodes sorted by probability of having the object. For put operation, it means the list of nodes and the order to put the object so it would be found by others with a higher chance. Let's assume the policy says to store each object in 3 replicas. So NeoFS node will put the object copies to nodes A, B, and D. Nodes in NeoFS may fail or new storage nodes may be added. All the changes are reflected in network map. But it doesn't happen immediately. During some period of time, inner-ring nodes accumulate changes in network map and then issue its new version. This period of time is called epoch. Epoch has a number and it's monotonically increasing. On each epoch change, all storage nodes are recalculating object locations to fit current epoch network map placement rules. If we need to move some data because of such changes, we call this process migration. For example, when new epoch comes, we notice that node B is gone. Nodes will call placement function and see where the object should be located now. Node A will replicate object to node C. And node D will move the object to node E. Now everything matches the placement policy for current state of NeoFS network. But what happens if some node is up and running, but the object there is lost because of some disk failure? It will be replicated. Storage nodes are constantly checking objects they store and make sure other nodes do it as well. If a node finds out some object is lost or corrupted for some reason, it will restore the object from other replicas. This is Bob. He wants to download the cat movie. He calls CLI, which calculates which node stores the object using the same placement function as we've seen before. Bob uses big object ID to get the movie, but behind the scene, NeoFS nodes will understand that it should be assembled from the smaller parts and return the movie in the same form as it was uploaded by Alice. Now Bob has a hilarious cat movie.